Okay. Cluster analysis, basic concepts and algorithms. Here, you can refer to the book Introduction to Data Mining, and these are the units that we are going to cover in this chapter. You can refer those units for your own reading purpose. So, we will be covering the introduction, what is basically clustering, what is the motivation, and various design aspects included. Then one type of clustering called partitional clustering, and then another type hierarchical clustering. Also, in each of the type of clustering, we will be seeing specific algorithms meant for that particular type of clustering. So some of those types are k-means. Then we will see dendrogram in hierarchical clustering, and then last we will cover the DB scan algorithm. So first, let's see what is clustering. So clustering is actually a task of dividing the population or data points into a number of groups. Okay, and so that the data points in the same groups are more similar to other data points in the same group than those in other groups. So in simple words, we can say that our aim in clustering is to segregate the groups with similar traits and assign them into clusters. Okay. So let's say suppose we take an example. Let's say you are the head of a rental store, and you want to understand the preference of your customers to scale up your business. You want to make some updations. Um, so if you can, if it's possible, you can look at the details of each of the customer, and then propose or think of a unique business strategy for each one of them. So is it feasible? No. Looking at every customer's detail and creating a business strategy, it is not something you want to do. It can be very tedious. So in that case, what you can do is to cluster all of your consumers or customers, say into 10 groups based on their purchasing habits, and you can use a separate strategy for for customers in each of the 10 groups. So 10 groups will have their individual traits or characteristics. So this type of arrangement, that's what we call as the clustering analysis. So here one example is given. You can see there are totally 3 clusters in there, and most of the time, to have effective or efficient cluster analysis, you would like to have intra-cluster distances to be minimized or inter-cluster distances to be maximized. So if in between the clusters you can improve the or increase the distances, then that will form more segregated clusters. And also if you can uh, minimize the distances in between each of the data points inside a cluster, that will also give you more effective results. Just one moment, the meeting is logged right now. I need to unlock it. Okay. So this is a basic background about your clustering. Let's see some of the applications of the cluster analysis. So first, what are the applications? If we look into that, some of the basic applications are, there can be biologists which have applied clustering to analyze a large amount of genetic information which are available. And one of the example can be, clustering has been used to find group of genes that have similar functions. Okay, so based on the similar characteristics of genes, we can uh, perform clustering. Then we have a vast amount of data in our world wide web in internet consisting of billions of web pages. Then we can use clustering to group similar type of information into a number of clusters, and each of which they can capture a particular aspect of a query that you want to ask to your world wide web or the internet. It can also be used to find patterns in atmospheric pressure, or let's say you want to find out the ocean temperature that have significant impact on climate. Then you can use in various fields or applications such as medicine field or business field, or to predict stocks, what will be the future prediction of the stocks, how it will perform after a certain period of time. So these are some of the explanations. So to summarize, so many data analysis techniques, so they have time and space complexity. Okay, so if we have in terms of clustering, if we have m as the number of objects, m, just take it as a number of objects, and which are not just practical for large data sets. Okay, so you can just take that if you have number of objects as m, the complexity can be order of m square. Twice it can just take twice amount of time and space complexity. So however, instead of applying the algorithm to the entire data set, it can be applied to a reduced data set consisting of cluster prototypes. So after the applications, we can look at some of the design requirements and challenges. So applying approaches to different large data set, it's not always easy. It's never easy actually. There are different um, features or characteristics you have to look into. So some of the challenges can be, one of it is scalability. So it depends on how big or how what is the scale of the data. Okay, so clustering all the data instead of just only samples. Then if you have to deal with different types of attributes, let's take you have seen different attributes, so numerical, binary, categorical, ordinal. So different types of attributes, they have their own specificity about application of clustering on them. Then constraint based clustering, so user may give inputs on constraint. So what type of limitation or constraint you are imposing on your data, that also can affect the those type of input parameters can also affect your clustering. Then there are other different types of design or challenges also available. So if you have different types of shapes of clusters, that can also affect your results. Then if you have noise or no, we will look into that. What is a noise? Noise is also called as a outlier. So if we have a lot of noisy data inside the data set, in that case, what happens to the clustering? Then if you have high dimension of data, so if you have a large scale of data, so what happens in that case also? So these are different types of aspects which can affect the clustering. Then types of clusters. So if you look into type of clusters, there is a most important function called objective function which comes to a picture. So clusters are always defined by an objective function. And um, what happens here, you need to always find the clusters or define the clusters which can minimize or maximize the objective function. So in every clustering approach, you need to find out or iterate over different possible ways of dividing the points into clusters, which point will be assigned to which cluster. So that again will be evaluated in certain terms. So we basically evaluate in terms of goodness. So it is called a goodness. And sometimes this goodness is, most of the time, the goodness is actually related to the objective function. And in the basis of objective function, which is again, which for the determination of objective function is also complex at certain times, and it is also called as NP hard. It is very complex to deal with or manage that objective function to make clustering or form clustering. And so this is your objective function. So we have different types of objectives: local objective, global objective. So we will look into that while we move through our slides in different types of clustering. So hierarchical clustering is typically it has the local objectives and partitional ones. they typically deal with global objectives. So, in order to, I mean, how the objective function actually varies and how does it actually fit into the model. So, in that terms, your parameters of the model are determined from the data. So, what type of parameter, what type of data it is, what are the different parameters you are going to set to fit your model or to train your model, and then you want to apply clustering on it. So this is about your objective function. Then comes the characteristic of input data. So directly you just cannot apply the clustering on the input data. There you have to look into the data. I mean, how does the data actually looks? What is the proximity density measure? I mean, if you have different data points in a cluster, how close are they or how far are they and how dense are they? So are the points placed close to each other, whether the region is dense enough or it's sparse enough? So those are the measures which are very much important in case of clustering. So proximity measures are always central to clustering and it depends on the data mostly. So various data characteristics that mostly affect the proximity and density, these are dimensionality, how the data is actually distributed. It deals with that. What are the data attribute types? Then what are the relationships in between the data? Then what are the different noise or outliers? Noise means what? Certain data points which have uh, like so much very different type of characteristics than the than the other points that are available in the data set. So those are considered as your noise or outliers. These are some of the important characteristics in the input data we need to look into before applying the clustering. Then types of clustering. So clustering is one. What? A clustering is a set of clusters. So if you have a set of clusters for a given data set, then you will apply the clustering approach on it. So if you look into the partitional and the hierarchical clustering, so in the partitional clustering, so all those data objects or data points are divided into non-overlapping subsets or the clusters such that each of the data object is in exactly one subset. So how it actually works, we will look into the algorithm in the case of partitional clustering. And in the case of hierarchical clustering, here a set of nested clusters are shown in the form of a hierarchical tree. We also call it as dendrogram. I have shown you in the initial slides. So dendrogram is a best example of your hierarchical clustering. We will construct some of the hierarchical tree, or we will see or also see how the dendrogram is actually formed or created on the basis of an input data. Okay, so partitional clustering. What happens actually? Let's say you have original points in this way. Then if you want to perform partitional clustering on it, so a division of set of data objects into non-overlapping subsets or clusters such that each data object is exactly in one subset. So taking the data into consideration, uh, you have to form non-overlapping subsets. So some of the cluster data points will be defined in one of the cluster. So that each data object is exactly in one subset. Then the hierarchical clustering. So hierarchical clustering, the important example is your dendrogram. So dendrogram is, it actually looks like this. So if you have data points in this way, P1, P2, P3, P4. So based on the, let's look into this one, the traditional hierarchical clustering, nested cluster diagram. Let's first look into this one. So how the clustering is actually formed. The P2 P3, they are more closer to each other. So first this cluster is formed. Then looking into this P2 P3 cluster central point or centroid, we will find the distance between the other 2 points available, that is P1 P2. Whichever is the closest, that is P4, will be enclosed inside another one cluster. Then the rest, that is P1, will form another cluster around that. If the same process is to be performed, and then in the hierarchical clustering, if we want to form a dendrogram, it will be formed in this way. So first P2 P3 are formed in a cluster, then the combination of it is formed in another cluster along with P4, then comes the P1. Okay, then another one that was traditional. If we will go non-traditional way, so we will just take P1 P2 in one cluster and P3 P4 in one cluster, then we will enclose all of them together. So that one can be shown in a dendrogram in this way. So this tree structure will give you a brief overlook of how the clustering is actually performed, in which order. First P1 P2 are clustered, P3 P4 are clustered, then both of them are clustered together to form another one final cluster. Up to this point, do you have any question? Okay, so now moving over with the clustering methods, first we will look into the partitional clustering. The most famous algorithm or type of clustering is your k-means. We will look into that. Then we will see what is objective function in partitional clustering, and what are the limitations or drawbacks of partitional clustering. So first, let's see evaluation of k-means cluster. So k-means clusters is always dependent on the formation of or the common measure of sum squared error, which is also called SSE, sum squared error. The short form is SSE. So for each point, the error is actually the distance to the nearest cluster from a certain given data point. So let's say you have in a data set, you have some data points such as like this, 4 data points are there. So again, you have the centroid of the data point, let's say at 0 0.5, 0 0.9, like this. Let's say you have two different centroid means central point of a cluster. So first you need to find out the difference between each data point to its defined centroids. 2 with this, 3 with 0 0.5, 3 with 9, 4 with 0 0.5, 4 with 0.9. So each of the distances will be calculated for the 4 data points with respect to the centroids. So once you found that one, then to get the SSE, we need to square these errors. So you need to square all these errors, then you just have to add them all together and it will give you the SSE. This is the basic formula of determining that. So whatever I explained, that is given by this formula here. Distance in between. So X is actually your data points in the cluster. Ci. So each cluster has a data point. One may belong to one cluster. 3 may belong to another one cluster. 2 may belong to the same cluster where 1 is in. So it depends on which cluster the data point belongs to. And Mi are the centroid points like the 0 0.5, 0 0.9. So yeah, so you got all of those. So first you need to find out square of the distance. So how to find out distance? Distance in between the centroid. Mm, and the Mi is the centroid or mean for the cluster Ci. So first you need to find out the distance between the centroid and the data point. Take the square, then add all of them together and it will give you the SSE. Okay. So if you have two sets of clusters and you have multiple errors, so there you have to choose the smallest error. Whichever is giving you smallest error, just pick that and start working on that. So actually SSE, let's say you are performing certain iterations in different steps. You are doing this analysis, okay, finding out the distances in between the points and the centroid, and then you are finding the SSE, that is sum squared error also. So in each step or each iteration, whatever SSE values you will have, looking into that, wherever you find the smallest error, that becomes your final solution. And in that case, it reaches the local or global minima, which is final. And one thing, when I mentioned the distance in between these MIX, so always the distance measure, if you remember, we have learned about the Euclidean distance, okay, in our second chapter, data. So if you look into that, you will find the formula of the Euclidean distance. So for distance calculation, you can always use the Euclidean distance for finding out the distance. So once you have the distance, just take the square of all the distances and then add them together to find out the SSE, that is sum squared error. Okay, and if two set of clusters are there which are produced by two different runs or iterations of k-means, then here we will always prefer the one with the smallest squared error. And since it means that the centroid of the clusterings are better representation of the points in that cluster. So SSE is most important in k-means to reach a local or global minima. So the procedure of finding k-means, first you need to make the guesses of initial means, that is M1, M2 up to Mk, if there are k number of clusters. Um, so you need to repeat certain steps here next until there is no change in the mean. So first you need to assign each data point to a cluster whose mean is nearest. So when you find the distances in between the centroid and the points, you always have to find out the smallest distance. Whichever is smallest distance, that distance is considered, and that there you need to define which cluster it will belong to, looking into the centroid of that cluster. Okay. Then after you are done with that, you need to calculate the mean of each the cluster again. This M1, M2, Mk values will be changed. You will do this again and again until there is no change in any mean. So for I from 1 to k, so for each cluster you need to replace the mi with the mean of all examples of cluster I. So in each step actually you need to find out the distances in between the data point and the cluster centroid, that is the mean, and from there you need to uh, also again find the mean. Okay, and that new mean will be replaced on the old means. So each time you just have to change or update the mean values until there is no change in any mean. This is the basic k-means algorithm. Let's see that in this picture here. Suppose here k means cluster, so two clusters, k value 2 is taken. Just we are just assuming it. So these are the some data points. Dark blue, light blue, and red colors. So first you need to assign each objects, that is data points, to the most similar center. So here what happens, from here in the data set, when you apply k-means, it will first find out a mean or centroid. So whichever data points are close to whichever centroid, it will form cluster. So here it just formed two clusters. Then after forming the cluster, the centroid or the mean is need to be determined. The red points are the mean. Okay. Then again reassign. So when reassign it, um, so based on the distances in between the points, these groups are again formed. Again you update the means. So each time the cluster formation shape and the points are moving in between. Okay, and the centroids are also moving in between. So like this you will repeatedly do this until your mean never changes. No change in any mean. Okay, so this thing will go on until, let's say, after the next step, when you again go on to update the cluster means, you don't find any change. The mean still remains there. That means this is the final answer or final result, and you should stick to that. And you will find out the output from the defined cluster, which is formed in the last step. Let's see this example. So first, here we have in the first iteration, these are all data points in different colors. So starting with three centroids. Okay. So there are 6 steps. So final clusters are found in 6 steps as shown. And at the end of iteration 3, you see the clusters are formed in close proximity to their individual clusters. So first the mean or the centroids are in this position. So based on that, the clustering is done. Okay. So again, mean value, when we found the mean value, they change to this one, this one, this one. The plus signs are the centroid or the mean. Then in the next step, next iteration, again new mean will be found out by the new cluster formation. So again the mean values are relocated. Now in iteration 4, again based on the new mean calculated, the clusterings are formed. So when you have the centroid here, all the data points will become brown color. This one green, this one blue. So that you see here. Then in the next step, what will happen? Your centroids will be formed to the more closer cluster data points. So these are 3. And the next step, when you find out the mean, you see there is no change. So you just have to stick to this one, and there you will finalize your result that you have 3 clusters and their own characteristics with their own centroid points. This is your basic clustering example. Um, so if you want to have details about the algorithm, it is a simple iterative algorithm. First, you need to just choose. I'm just going to iterate the same thing looking into this picture. So first you need to choose the initial centroids. Then you just have to repeat or assign each point to the nearest centroid and recompute the cluster centroids. You are re-evaluating the means again and again until the centroids stop changing, like it happened in this case, iteration 5 and 6. And always the initial centroids are chosen randomly. If you are supposed to if you are asked to perform a k-means operation on a data set, you should be given with a centroid points, or else you can assume it yourself. And always the centroid is actually or typically the mean of all the points available in the cluster. Okay. Now next, some details about the k-means clustering. As I told you, centroids are always chosen randomly and clusters produced can vary from one run to another depending on the mean or the centroid of the clusters. What is centroid? That you already know. And closeness. how do you define that which point will go to which cluster? It is defined by the distance, and that distance can be measured by Euclidean distance, most common distance measure. You can also take cosine similarity, and there is other operation called correlation. But most of the time we choose this Euclidean distance. Um, then most of the convergence can happen in first few iteration. So convergence means what? The stopping condition actually, when there will be no change in the mean values. So there, that is called your convergence or the stopping condition, and it can happen in the first few iteration. So if you have to define the time complexity, space complexity of the K-means algorithm, it will be order of all these. How many number of points, how many number of clusters to be formed, how many number of iterations, how many number of data points or attributes. Sorry, how many number of attributes. So all of them together are considered, all of them are multiplied together, and that will give rise to your complexity of this algorithm. Then next comes first initial centroid problem. So when you randomly choose the initial centroid, is there any issue to that? If there is an issue, what are the solution to that? So you may have to perform multiple iterations, okay, to find out the initial centroid, but that solution may not be always in your own side. And you can use the hierarchical clustering to determine the initial centroids, and to generate a large number of clusters. Also, the hierarchical clustering is helpful. There is another one, bisecting K-means, which is somewhat also helpful in this issue, that is initial centroid problem. Then the disadvantage of K-means. So what are the disadvantages? Um, so initial guess, how do you initially guess the centroid or the mean? That is your M value in the clusters. That is a, if it is a bad guess, it will also badly affect your solution. Then what is the K value? How to assume that K value? So that is again another one issue. And K-means algorithm also does have some of the problems with differing sizes of the clusters, densities, or different types of non-globular shapes. We will look into them in the next slides. And outliers. If you have noise in your data or outlier in your data, that can also significantly affect your K-means clustering solution. Another example here, see the different cluster sizes. As the original clusters, if the cluster sizes are different, then as the second picture shows, it is very difficult to show the differentiation. Okay, if there are supposed to be three clusters, how do you define them? This cluster may be different to this cluster may be different to this cluster. So it doesn't work well with the differing sizes. If you have different density in this way, here it is having more dense area, again more dense, and this is more sparse. So in this case also, it is not helpful. This more dense area, it has two centroids, whereas this one has one centroid. It can also, in this case also, it is not really helpful to find out any result particularly. Then let's see this one, non-globular shapes. So if the original points are in this type of shape, then here also it is very difficult where to set up the centroid and how to differentiate the clusters. And it may not always give you the correct solution. Then next, overcoming the K-means limitations. So how to actually overcome all those limitations? What to do actually? The solution is, if you have the points in this way, in the original points plot, so the solution can be, you can form many number of clusters and then put them together depending on the centroid. If you have many clusters, many centroids, so define your points based on that. Then again compare them to find out the similarity in between in between different clusters together. So this is all about your K-means algorithm. So next class, I will start with hierarchical clustering.